In this video, we're going to look at how we can plot a graph of current against potential difference for a resistor, a fixed resistor in a series circuit. So in order to do this, we're going to use a PhET simulation. And obviously we need to create our circuit first. So we drag across a cell. By clicking the button in the middle of it, the minus on it, we can set the potential difference to 0 volts. We then drag across a resistor, and again clicking in the middle of it, we can set the resistance to 10 ohms. Now I need to put an ammeter in the circuit. Now remember, ammeters are part of the circuit, they're in series, and hence we connect it to either end, so it becomes part of the loop, and now we just connect the wires together in order to make a complete circuit. Now I can't rely on the potential difference across the battery, which we actually call an electromotive force. It's called an electromotive force, not surprisingly, because it's an electromotive force. It's a force that moves electrons. We need to use a voltmeter across the resistor. Now notice it's across, not in series. So these ones, voltmeters, go in parallel. So we connect it to either side of the resistor. And now we need to take some measurements and put them in our table. You can either use a spreadsheet or you can do it in a book. And not surprisingly, when the potential difference of the cell, the electromotive force, is 0, there's no current. And no current, obviously, because there's no force. If there's no force, there's no change in motion. And those electrons aren't going to whiz round on their own. They need something to force them round. So we put 0, 0 into the table. As we change the potential difference, we put it up as 1 volt, 2 volts, 3 volts, etc. We just put the reading on the ammeter into the table until we have a complete table. You may want to compare different resistors. So having done 10 ohm resistor, in this case I'm going to use a 20 ohm resistor, we can just click on the button again and increase the resistance to whatever the required level is. And we'd repeat the process, filling in the table. Now, the most important thing about this is not carrying out the investigation. The most important thing is, what can we learn from it? What patterns can you see? What happens when I double the electromotive force across a resistor? Does the current also double? What happens if I double the resistance to the current? Is it easier to push a current through a higher resistance, or is it harder? We now need to plot a chart from our spreadsheet results. So very easy to do this. I'm just using Google Sheets in this case. I need to highlight the table, not the top row, and go to Insert Chart. The chart may give you a line graph. If it doesn't give you a line graph, we need to change that. And we change that through the Customize. We go to Line Chart as opposed to a Scatter or whatever else it's actually giving you. And once you've done that, you can just drag it into place, screenshot it, or find some way of submitting it. The main thing is to look at it. What does the line mean? What does the gradient of the line measure? If you've used 2 or more, then what you need to do is actually highlight all 3 columns again, not the first row, and do the same thing, insert the chart. This time the chart will plot you 2 lines. There's a couple of things which you need to notice on it, which you need to try and change, is the fact that the title does not tend to give you a reasonable title. And also, when we go to the chart, let's just have a look here, the y-axis is not labeled. So you can look at yourself of how you could potentially do that. I'll just show you how to change the chart title to something which is more appropriate. The most important thing is to look at the lines and to see what they signify. What's the story of those 2 lines? So if we look at the blue line, that's a 10 ohm resistor, and we compare it to the red line, which is the 20 ohm resistor, we'll notice that the gradient of the 10 ohm resistor is higher than the gradient of the 20 ohm resistor. what's that mean? What's the gradient actually measuring? Is it measuring resistance or is it measuring something else?